Welcome to the Robotics Through Science Fiction podcast. I'm Robin Murphy, and in this episode, I'll review the 1972 must-see robot movie called Silent Running by Douglas Turnbull, the special effects wizard from 2001: A Space Odyssey. The movie's set in a nearish future. The last forests have been relocated by unappreciative, environmentally reprehensible human race to space stations, in effect, terrariums in space. The terrariums are tended to by three little-legged robots called Huey, Dewey, and Louie after Donald Duck's nephews, and by some human misfits. When the bean counters on Earth tally up the cost of having forests in space that no one cares about and they can't visit, they order their destruction. Fighting ensues between the a-hole crew members who are happy to nuke the forest and return home, and the crazy Gone All Sierra Club crew member Lowell, who wants to disobey and save the forest. For anyone too dense to miss the pro-environmentalist plot, Joan Baez, the iconic folk singer who's normally subtly evocative, sings the most overtly cloying Save the Trees song ever. Yes. This is a movie worthy of Mystery Science Theater 3000, and according to the Internet Movie Database, it actually inspired that show. Despite the dose of dreadful earnestness, Silent Running is actually pretty accurate about robots. The director, Douglas Turnbull, hot off his special effects work with Kubrick, was all about technical realism. Maintaining a space station in the harsh vacuum and radiation of space requires robots, as NASA learned decades ago, so bingo, Turnbull put in robots. Good man. What is particularly accurate about the robots is how Silent Running portrays the multi-robot coordination. Multiple robots offer many advantages. Some are that several robots can tackle tasks that a single robot can't do, something like move something heavy. And they can cover more area faster, or they can simultaneously protect an area. Ideally, many robots would be cheaper than just one based on economy of scale. Now, writers tend to assume a centralized control paradigm for multi-robot systems where one computer or robot controls all the robots in a master-slave type of arrangement. That's particularly convenient for plots where the centralized computer is out to take over the world, like Vicky and iRobot. Centralized control of robots has many problems in practice in real life. A big one is that if the centralized controller is down for maintenance or perhaps destroyed, say by a young Anakin Skywalker in The Phantom Menace, then all the robots become useless. Joke's on you, Trade Federation. You may be able to control the galaxy's monetary supply, but you made a rookie mistake in robotics. AI researchers in multi-robot systems tend to focus on the distributed control paradigm, where each robot has at least a little independent intelligence and their own responsibilities. Now, distributed control raises different challenges. One fundamental challenge is determining how independent and what is the minimum intelligence can the robots have to get the jobs done. And are the robots aware of each other, and do they communicate directly with each other like wolves yipping to coordinate a hunt? Or are they only indirectly aware of each other and communicate through direct perception of the state of the world or through stigmergy? Stigmergy is a biological mechanism where the action of one animal leaves a trace behind that influences the next action taken by another animal. Ants leaving a pheromone trail behind for the other ants to follow. A really nice example of exploiting direct perception and avoiding complex reasoning in the real world was work done by Lynn Parker in box pushing. She had a team of robots push boxes that were too heavy for a single robot to push. Each robot would start pushing and could sense whether the box surface was flat to the touch or jutting in or out. If the box was jutting in, the little robot would push harder, even though it didn't know anything about how many other robots there were or how they were pushing. It was just stimulus response. If the box was jutting away, the robot would slack off, thus giving all the others time to catch up. If the box was flat, then the robot would maintain its force and trajectory. Notice that the robots did not have to know how many other robots were involved or communicate directly with the others. They communicated indirectly via the box. Plus, it means it still works even if a person was moving one side of the box. The robot doesn't know or care. Jutting in, jutting out, flat. Another question that a designer of a multi-robot team has to consider is whether the robot should be the same or different. Identical robots or homogeneous robots working together are often programmed to behave as swarms of insects. A swarm in robotics implies that the individual robots emulate insect intelligence and have a simple mechanical design so that having hundreds or thousands of robots is economically feasible. Huey, Dewey, and Louie were homogeneous, but not a swarm, as each was independently highly intelligent and directly communicated and negotiated with each other as to who did what when. Yet another research challenge is determining in advance how many robots are needed to guarantee accomplishing a task. If there are too many robots working on a task, especially if they're acting like an insect-like swarm, it can actually degrade the overall task performance. An example of the old adage, too many cooks spoil the broth. In robotics, that phenomenon is called interference. Of course, centralized control has a major advantage. It may be optimal on a global scale. In silent running, Louie, limited by its local perception of the situation, couldn't perceive the bigger picture and ignored the advice from Lowell, who had a better global view of the situation. Instead, Louie, like an animal or person, trusted its own judgment. Highly realistic from a robotics programming standpoint, and sadly, highly realistic from a consequences perspective. So, how did Trumbull make Huey, Dewey, and Louie? They seem so naturally. Well, here's where the movie is more appropriate for discussion with older kids. The robots are actually multiple amputees walking on their hands. Really. It does afford an opportunity to flip the image of the disabled playing the robots and discuss how robots could help the disabled. But wow. Notice that when the robots stop to get directions from Lowell or other crew members, they sit down. In a robot, it would be natural to do this to conserve energy. In a person, it was for the actors to reduce fatigue. Likewise, the robots turn slightly to pay attention to the humans walking by, or they turn and move in ways consistent with conversational poses and gestures. Nice. So, is silent running deserving of cult movie status? Well, maybe not for its overall contributions to apparatus theory and film studies, but definitely for its cinema verite incorporation of robots. Huey and Louie, rest in peace, and Dewey, keep up that good work in that big force in the sky. And someone, please mute Joan Baez.